Now I introduce of policy actor critical algorithm. For the continuous action reinforcement learning problems, policy gradient method is the best way to solve the problem to find the optimal policy. Based on the Markov decision process, we define the objective function G. G is the function for policy. Based on the Markov decision process, we can express this objective function as a state distribution, policy, and Q function. To use the gradient method, we need to calculate the gradient of the objective function. Since this is not a function of theta, we can directly calculate this one. To express this integral as a expectation, so we use a relationship here to change the integral from here to here, and then since this distribution, this S sampled from rho, and this action sampled from this policy distribution, so we can change to the expectation formulation. In the actor critical method, this policy uses actor to select action, and Q function is use a critic to evaluate this policy, see is good or not. However, this Q function not only depends on the action selected by under this policy, it depends on the whole trajectory until the terminal. Since this policy is stochastic, we no way to determine the real Q function. That's why we cannot directly use Q as a critic to evaluate the policy. Now in the stochastic actor critical method we introduced before, we use approximator Q, W. Then we add some strict on the W to make sure we have no bias, we have accurate, we can get the final accurate policy. However, in too much, the condition is too strict, so it's not really a actor critical method we want to use. That's why we change to another way. They use the off policy actor critical method. Off the policy means the policy not generated from the online. It's from somewhere else. Let's say we have a behavioral policy beta. We use this beta policy to generate a trajectory. In turn, this trajectory used to evaluate the alpha policy pi. And that's called the importance sampling. We use this idea to search for the optimal policy pi. To use the alpha policy, we need to change the objective function a little bit. We not use the pi, times Q, because Q is unknown for the stochastic policy. However, for example, we use this policy beta from this state S generate a trajectory, from S until to the terminal. Since this Q is unknown, we cannot use as the critic, but we know the value state function because this, no matter we use stochastic policy, no matter how can we select this A, but we only have we know the true value function. So we use the value function as the critic to value the policy, and still we use generate policy network. We use generate network. We use his parameter to improve the policy at the same time to improve the policy beta, and let this objective function as a minimum. To do so, we need to get the gradient of the objective modified objective function, and then we have calculate the derivative of the policy here, and then we use this, again we use this formulation. We have this pi and this q, because q is true. Q is unknown. We cannot use q as a critic to use the q as a critic to evaluate the policy, but however, we this pi times q is v, but this value function is known. We use this v as the critic to evaluate the function, the policy pi. Here is that's why we change it to q, from q to the v to as a critic to evaluate the policy. After we change this, because right now is using importance sampling, so the state is sampled from row. This row is under policy beta, and this action also is sampled from policy beta. For more details, please check with this reference. Thank you. Bye.